Hello everyone, welcome to my channel. My name is Deepika, and on this channel I share simple and clear explanation of matter. So in today's video we will learning about matter and its nature. So here we are going to learn about few important topics that will help you understand better. We will start by looking at the definition of matter, then move on to the properties of matter, states of matter, properties of every states of matter, change in state of matter, classification of matter, kinetic theory of matter, and finally, we will explore the real life examples. So first, we will understand what is matter? Everything around us, including air, water, food, even our bodies, is matter. In simple terms, if something can be touched, seen, felt, and occupy space, is considered as matter. But things like light, sound, and heat is not are not considered as matter because they don't have mass and take up space. Now, let's move on where we will look at the properties of matter. Matter has certain characteristics that help us identify and describe it. As before discussed, matter is anything that has mass and occupies space. So here you can observe two main physical properties, that is mass and volume. Here you can see few pictures. In the first picture, we can see few pieces of ice. Ice is a solid. It has mass and it takes up space and has some weight. It also has fixed volume, meaning its shape and size stay the same unless it melts. So a cube of ice will always keep its shape until it turns into water. In the next picture, there's a liquid in a bottle. This liquid is in a liquid state, which means it has fixed volume but no fixed shape. It takes the shape of the container it's in. Liquid can flow and you can pour them. It takes shape of container you pour it into, but the amount stays same. In the third picture, there is a here you can see there's a few amount of salt. It is solid. It is made up of tiny grains. It has definite shape and size. For each grain, it can dissolve in water. So solubility is another physical property. We will discuss it later. Now, we will move on to the state of matter. Matter exists in different states, mainly solid, liquid, and gas. Most of us know the three common states of matter, but scientists have discovered two more, plasma and BEC, Bose-Einstein condensate. Let's look at all five. In the solid state, it has fixed shape and volume. We cannot compress it, and particles are packed tightly. For example, ice, rock, wood. In the liquid state, it has fixed volume but no fixed shape. It takes the shape of container where it into. For example, water, juice, oil, and in the gaseous state, it has no fixed shape and volume. It is highly compressible. Its particles move freely. For example, air, oxygen. In the plasma state, it is very high energy state of matter. High energy state. Its particles are charged. They move very fast. It is found in stars, sun, lightning, neon sign, and plasma TVs. BEC, Bose-Einstein condensate. It is very low energy state of matter. Very low energy state of matter. It happens when particles are cooled near absolute zero. The particles come together and behave like single particle. It is only seen in labs using atom like rubidium at supercool temperature. Now, let's move on to the next point, that is properties of matter. Here, we will discuss the properties of solid, liquid, and gas, and we will see all these properties are interconnected. Now, let's take a look at this comparison table that highlights the key difference between solid, liquid, and gas at molecular level. As you can see, the table compares several properties such as molecular arrangement, intermolecular forces, molecular movement, shape, volume, compressibility, and energy level. So, starting with the molecular arrangement, in solid state, molecules are tightly packed in a fixed pattern, and in liquid, molecules are loosely packed. They are close but not in fixed position. And in gas, molecules are far apart. These molecules can move freely, or you can say they are randomly arranged. Next, look at the intermolecular forces. This is very important property, and first of all, we need to know what is intermolecular forces. So, intermolecular forces are the forces that pull molecule towards each other. They are like sticky forces. These forces decide that things are like whether something is solid, liquid, or gas. So, in solid, intermolecular forces are very strong. These strong forces keep the particles tightly packed. Here you can see in this picture, all the molecules in solids are tightly packed in fixed position. In liquid, forces are weaker than solid or moderate. They are strong enough to keep particles close together, giving liquids a definite volume. Here you can see molecules are loosely packed and the forces are moderate. Intermolecular forces are moderate. If we are talking about gases, intermolecular forces are very weak. Intermolecular forces are weakest in gases or almost non-existent. This allows gas particles to move freely and spread far apart. So, the strength of intermolecular forces plays a key role in determining the behavior and properties of matter in each state. As we go from solid to liquid to gas, molecular movement increases and intermolecular forces decreases. In next property that we are going to compare is molecular movement. As we discussed in solid, molecules are tightly packed and only vibrate in place. They cannot move freely due to strong intermolecular forces. In liquids, as we know, molecules are close together but not in fixed position. They can move and slide past one another, allowing liquid to flow and take the shape of their container while keeping the volume fixed. In gases, molecules move rapidly and freely in all directions. They are far apart due to weak intermolecular forces, which allow gases to expand and fill any space or container. So, as we go from solid to liquid to gas, molecular movement increases due to decreased intermolecular forces. Moving to the next point, shape. Because molecules are tightly packed, solids have definite shape. The particles are tightly packed in a fixed arrangement. So solid keep their shape even when moved from one place to another place. In liquid, there is no fixed shape. It takes the shape of container but does not expand to fill it. And gases neither a fixed shape nor a fixed volume. No fixed shape and spread out completely. The particles move freely and spread out. So a gas fills the entire shape of any container it's in. In short, the shape of matter depends on how freely its particle can move and which is controlled by intermolecular forces. Moving to the next property, volume, which we have already discussed. In solid, volume does not change. It has fixed volume. In liquid, volume fixed, but shape change. Fixed volume, but shape changes. It takes the shape of container it pour into. And in gaseous state, there is no fixed volume and it expand to fill the container. Next property is compressibility. Solid are incompressible. It cannot compressed. There is no space between particle to push them closer. But in liquid, they are slightly compressible, but not easily. Liquid molecules have very little space to reduce. But in gases, gases are highly compressible because their particles are far apart. When pressure applied, the particles can be pushed much closer together. Here I am showing few examples of compressed air. When you press down bicycle pump, when you press down a bicycle pump, you are compressing the air inside the cylinder. Another example is gas cylinder. In gas cylinder, where oxygen or LPG is stored under high pressure by compressing large volume of gas into small container. Here we oxygen and LPG gas are filled by compressing large volume of gas into small container. In a scuba tank, air compressed so diver can carry enough oxygen underwater. Next point is energy level. In solid, particle have least amount of energy, that is lowest kinetic energy. They only vibrate in place because they are tightly packed and held together by strong intermolecular forces. In liquid, particles have medium kinetic energy, more than solid. They can move around and slide past each other, which is why liquid can flow. And in gases, particles have highest kinetic energy. They move quickly and freely in all directions because of weak intermolecular forces. So we can see energy level increases from solid to liquid to gas. Here I am sharing few examples of solid, liquid and gas. These are the examples of solid and these are the examples of liquid, that is water, milk, oil, and air and oxygen and steam are the example of gas. So apart from that, you have lots of examples around you. So moving to the next topic, change in state of matter. As we know, matter exists in three main states: solid, liquid, and gas. A matter can change from one state to another when temperature or pressure changes. It happens when we add or remove heat. This affects the movement of particles and cause matter to change from one state to another. There are the different types of changes that we can observe. First is melting. So what happens in it? Have you seen at your home butter melt on a hot pan or ice cube melt when you take it out from the freezer? This is because when a solid is heated, its particles gain energy and start moving more freely. At certain temperature, the solid turn into liquid. This is called melting. That is, conversion of liquid by heating is called melting. Next is freezing. When you place water in a freezer, it turns into ice. So what happens in freezing? When a liquid is cooled, it loses heat energy and its particles slow down at freezing point and it becomes a solid. For example, water freezes to form ice. That means liquid state changes into solid by cooling is called freezing. Next is evaporation. Here you can see the picture of boiling water. This is the example of evaporation. On heating a liquid, the particle move faster. At boiling point, the liquid become gas. That is, conversion of liquid to gas by heating is called evaporation. Next is condensation. Rain is a natural example of condensation. Water from ocean, river and lakes evaporate and rises into the air as water vapor. As water vapor rises, it cools in the upper atmosphere. The cool air causes the upper layer of vapor to condense into tiny water droplets, forming clouds. When these droplets join together and become heavy, they fall as rain. So, rain occurs because of condensation of water vapor. In short, conversion of gas to liquid by cooling is called condensation. Next is sublimation. Some solids change directly into gas without becoming a liquid, like camphor or dry ice. What is dry ice? Dry ice is a solid form of CO2, unlike regular ice. Dry ice does not melt into a liquid, it changes directly from solid to gas. It is used in keeping food cold during shipping. It is also used in creating fog or smoke effect in movies and stage shows. Another great example is camphor. As we gently heat the camphor, you will notice it slowly disappear without forming any liquid. That disappearing act is sublimation. Next is deposition. It, it is change in state of matter where a gas changes directly into a solid without becoming a liquid. For example, frost formation. Water vapor in the air changes directly into ice crystal on cold surface like grass, windows, especially on chilly morning. Deposition happen when a gas loses a lot of heat quickly, so the particle does not have time to become a liquid. That is frost formation. Now, next topic that we are going to discuss is classification of matter. Matter can be broadly classified into two main categories based on its composition: mixture and pure substance. Mixture is a combination of two or more substances that are physically combined but not chemically bonded. That means components retain individual properties, but pure substances are made up of only one kind of particles that have fixed physical and chemical properties. That means pure substance has a uniform and definite composition and cannot be separated by physical means like elements and compound. What are elements? Elements are made up of only one type of atom that cannot be broken down by chemical means like oxygen and gold. On the other hand, compounds are made up of two or more elements that are chemically combined in fixed proportion like water, CO2, NaCl, etc. They can be broken down into element by chemical means but cannot be broken down by physical process. Now we will talk about mixture. Mixture is of two types: homogeneous and heterogeneous. Homogeneous solution is a mixture in which the combination is uniform throughout. Its components are not visible separately. For example, sugar in water, salt water, air. But heterogeneous solution is a mixture in which composition is not uniform throughout. That is, different parts of the mixture are visibly distinct, like oil and water, fruit salad, sand and iron fillings. So, in heterogeneous component can be visibly separated. Next, I am explaining kinetic theory of matter, which explain the behavior of matter. The kinetic theory of matter states that all matter is made up of tiny particles that are in constant motion, and this motion depends on temperature and state of matter. The state of matter depends on the energy of the particle and the forces between them. Here, main postulates of kinetic theory that we are going to discuss. As we already discussed, matter is made up of particles, small particles, and these particles are in constant motion, constant random motion. The particles have space between them which increases from solid to liquid to gas. The energy of motion, that is kinetic energy, increases with temperature. That is, temperature affect particle motion. On increasing temperature, particles gain more energy. They move faster and more freely. And this can lead to expansion and spread out faster. And that leads to change in state. Like on heating, water molecule speed up until it boil and turn into steam. On decreasing temperature, particles lose energy, they move slower. This can cause contraction and change of state, like liquid freezes to solid. Next postulate is particle collide with each other and with the container wall too. Effect of pressure. We will discuss the effect of temperature and pressure separately. First, we will discuss the effect of temperature. As above discussed, when we increase temperature, kinetic energy of particle increases and particle move faster. That lead to expansion. For example, on heating, water molecule turn into steam. When we decrease temperature, the kinetic energy reduces and particle move slower. That leads to contraction. For example, water freezes to ice. Water turn into ice. And on increasing temperature, water turn into steam. Next is effect of pressure. Pressure affect the spacing and movement of particle. In matter, on increasing pressure, pushes gas particle closer together, reduces volume, and particle collide more frequently. That can lead to liquefaction. That can lead to liquefaction. That is gas turning into liquid under high pressure and low temperature. But in case of liquid, liquid slightly compressible under very high pressure, and solid, in case of solid, solid has very little effect because particles are already lightly packed, but in some cases very high pressure can deform and even break them. On decreasing pressure, particles move further apart and gas expand and more space occupies more space. If we are talking about liquid and solid, in case of liquid, if we decrease pressure, liquid boils at low temperature and evaporate faster. That is, boiling point decreases. Water boil at less than 100 degrees Celsius at high altitude, where pressure is lower, and lower pressure allows more molecule to escape into vapor. So evaporation becomes faster on decreasing pressure in case of liquid. Evaporation becomes faster when we decrease pressure. If we are talking about solid, solid are very rigid and incompressible. This is in case of liquid. Solid are very rigid and incompressible, so reducing pressure has little effect on volume. But some solid, like dry ice, can directly change into gas more easily. Here I'm showing few real life examples like boiling water, perfume spreading in a room, and diffusion of ink in water. In boiling water, when we boil water, the kinetic energy of particle increases. They move faster and collide more energetically. When the particles have enough energy to break free from the attractive forces, bubbles of vapor from inside the liquid and rise to the surface. These water vapor is water in gas state. Next example is perfume spreading in a room. In this, gas particle move randomly due to kinetic energy of the particle. Next is diffusion of ink in water. In this, liquid particles mix due to motion of particles. So today we learned all about matter and its real life examples. If you found this helpful, don't forget to thumbs up and hit the bell icon for more. Thanks for watching. See you in the next video. Bye bye.